Good morning, grade 12s. My name is Longta Plessis. I had the privilege to meet you yesterday, and I will still continue your teaching for today. Today, we are going to look at functions, like I said yesterday. It is for me vitally important that we use today as a good revision, as functions is quite a large portion of your paper one. So I'm going to start sharing my screen so that we can look at the PowerPoint. I hope you have your notes open in front of you. Okay. Right. As I said, grade 12s, we are doing functions. Um, we are going to quickly look at a little bit of revision of functions. So we have four main functions, which is the straight line, the parabola, hyperbola, and the exponential. Each one of those functions have the standard form of equations. At the straight line, that is y is equal to mx plus c. But at the parabola, we've got the standard form, the turning point form, as well as the x-intercept form. The hyperbola has their standard form, where we can see the shifting of left and right by p, as well as up and down. So the vertical shifting by q, and the exponential function in standard form as well as the horizontal and the vertical shifting. What do I need to sketch the graph? Each one of these graphs have x-intercepts. If I want to create or find the x-intercepts, we know we need to go and set the y value equal to 0. If we want to find the y-intercept, the same for each one, they will have to set x equal to 0. By the parabola specifically, we have a turning point. So we have two ways now in grade 12 how to get the turning point. One we've learned in grade 11, which is x is equal to minus b over 2a. And in grade 12, we've learned that we can do the first derivative. That's when we did our cubic functions. When we do the first derivative, set it equal to 0. We can use that same function or that same method we can use by the parabola. When we look at the hyperbola has two asymptotes. The equations for which is x is equal to negative p and y is equal to q. The exponential graph has only one asymptote, which is y is equal to q. There's just an example of how a parabola would look. That will be a happy face, which means a is greater than 0. The hyperbola, which is there will be two arms that goes about, and this is also where a is greater than 0. So it's quadrant 1 and 3. And then your exponential graph, here you've got, here you can see by the hyperbola, you can see you've got two asymptotes. By the exponential, we only have one asymptote as the graph has shifted downwards. When we look at the specific revision according to the parabola, like I said, standard form, turning point, and x-intercept form. If I want the turning point form, I've got the x value, which is minus b over 2a, and y, and just sub the x value back into the original equation. If I'm looking at the turning point form, I can actually just extract the turning point from here, where I have the p value and the q value. And then the x-intercept form, I have to do the same method as by the standard form. I have to say x is equal to minus b over 2a, but you'll have to first write that into standard form in order to continue and go about. Inverse functions. So inverse functions is when we reflect y over the line y is equal to x. So when it's there, we've got inverse functions for straight line, parabola, as well as the exponential function. By the straight line, here I've got a normal straight line that is y is equal to 2x plus 6. There I can see the line y is equal to x. And when I do my reflection, I will reflect over that line. And that my axis of symmetry will be the line y is equal to x. The parabola, there's two ways it can be. If I've got a happy parabola, then I'm looking at this happy face here. But then I've got a reflection over the line y is equal to x. It means it will go and lie on its side, which we know that doesn't count as a function because it doesn't meet the requirements to be a function. The same here with the bottom one. If it is negative, means it's a sad function. It will look like this. The exponential graph, we've got y is equal to a to the power of x, and then obviously the inverse will be y is, or it could even be that I give you the inverse, which is y is equal to log ax. This is the main one that we normally do by inverse functions. We've got our graph here. You can see still the line y is equal to x. When we are looking, no, a is greater than 0 and b is a whole number, then we look like that. And then it obviously reflects over the line and it will be butterflying right to the other side. That will be our log function. So with class like we did yesterday, we're going to do the exact same thing today. So I'm going to give you 8 minutes to complete question 1 for me. And then we will look at our answers. I will quickly go through them with you. So good luck. You've got 8 minutes. All right, grade 12. So you had 8 minutes to complete that. So let us quickly look at the answers. So the first question was that you had to write down the equation of the asymptote. So from what we had through our revision, we should know that the equation of the asymptotes would be x is equal to p and y is equal to q. So if it is x is equal to p, then it will be x is equal to 3 and y is equal to 1. That would be our two answers. You don't need to write that. That was just for me to try to explain. 1.2, calculate the coordinates of the x and y intercepts of f, which means if I want the x-intercepts, I need to make y 0. So 0 is equal to 2 over x minus 3 plus 1. So this is a hyperbola. I didn't mention that when we started the question. This is a hyperbola. What must I do now? I'll take the positive 1 because I need to bring this x minus 3 up. So in order to do that, the easiest is to multiply to the other side. But I can only do that if this is alone on this side, which means the plus 1 needs to go over. Second reason why I want to take the plus 1 over is because the x minus 3, when I multiply it and I multiply with 0, then it disappears because it becomes then 0. So it's important for me to say when I say positive 1, carries over becomes negative 1, 2 over x minus 3. And we know when we say carry over, I'm going to use the words carry over, but we know we actually subtract 1 on this side and we subtract 1 on the other side. So now I'm able to multiply this to the other side. If it's divided on this side, multiply it, that's the inverse. So negative 1 x minus 3 is equal to 2. Multiply the brackets, negative x plus 3 is equal to 2. And then I've got negative x is equal to 2 minus 3, and negative x will be negative 1. And x will then be equal to positive 1. Right, and we had 1.3 that we had to sketch. So if I sketch, first thing that I do is I go and I sketch my asymptotes. So we've got 1, 2, 3, 4, and then my first asymptote will be the fact that I've got an asymptote by positive 3, and then I've got an asymptote by positive 1. I'm going to make my thing spread out a little bit more on my y-axis. So there I've got those two asymptotes, and then I've got a x-intercept at 1. Oh my goodness, I forgot to get the y-intercept. My apologies, grade 12s. Y-intercept obviously make x 0, so 2 over 0 minus 3 plus 1. It must be a long diagonally. My apologies. That gives me 1 over 3. Right, so now I've got my x-intercept, which was 1 and 0. My y-intercept is 0 and a third. So when I got 1 and 0, then I've got my coordinate here, 1 and 0. And then the third will be around about here, so 0 and a third. Which means that both my x-intercept and my y-intercept is in the same quadrant, and that means I will then have to get another point in order to go and draw the second arm of this hyperbola, which means I can choose any x value on the right hand side of my asymptote. So I choose my own x value. The x value that I'm going to choose is going to be 4. So 4 minus 3 plus 1. You don't even need to show me how you calculate it. That's 4 minus 3 is 1. So 2 over 1 is 2. 2 plus 1 gives me 3, which means I've got x is 4 and y is 3. So I went to find a specific y value for that x value. So if I go to 4, and then I need to go up to 3. 4 and 3. And then I can draw my second arm going through there. And we are done. Right, so that was question 1. I'm going to go back to my PowerPoint, and we are going to continue from there. Then grade 12s, I want you to complete question 4 for me. That will be on page 8 of your learner notes. So we are just skipping a few questions. We're going to do the ones that I say first, and we might come back when we have time for the other ones. So I'm going to give you 20 minutes to complete question 4 for me on your own. Yeah, that's perfect. Thank you very much. And your time starts now. Okay, class, you had enough time for that one. Let us look together at the question. Question 4. Below we've got our graph F, which is our parabola, which is in turning point form, and we've got a straight line G. A and B are x-intercepts, and F and E is the turning point, so we've read all of those things. They want us in the first question to answer. Write out the coordinates of E. E is our turning point. And remember, we said that we received our function in turning point form. So that should have been fairly easy for you to write down. So all you have to write down is the fact that it will be 4.1. E is the coordinate of 4 and negative 9. Right? At 4.2. Calculate the coordinates of A. So A would be the x-intercept. So it means I need to go and find my x-intercept, make y 0. That is what we learned. So 0 is equal to x minus 4 squared minus 9. You don't need to be in standard form to answer this question. You can either go two ways. Either you can multiply the bracket, which will be x squared minus 8x plus 16 minus 9. And then it gives you x squared minus 8x positive 7. And then you will have x minus 7, x minus 1, x will be 7, or x will be 1. Right? So then obviously the coordinate of A would be 1 and 0. Because by the looks of it, A is closer to 0 than what B is. So A must be the 1. Or alternatively, I just want to show you, this would have been my preferred method. I take this negative 9 across to the other side. So that will be then 9 is equal to x minus 4 squared. To get rid of the square, I need to square root. But what I do then is I can't throw away one of my answers. I know I have to have two answers because x is the power of 2. Remember, we learned that yesterday. So I can just say plus and minus here. And then plus and minus 3 is equal to x minus 4. So if I take positive 3 and I carry the 4 across, it becomes a positive 4. So 3 plus 4 is 7. So x is equal to 7. Or you can take the negative 3, carry it across, then it will be negative 3 plus 4, and then x will be equal to 1. All right, so that is just another method that I wanted to show you. 4.3. They ask you, M is the reflection of C, and I want to show you the picture of that. M is the reflection of C in the axis of symmetry. So very importantly, we don't see the full axis of symmetry, but it is there, right? There is my axis of symmetry. And since C is a reflection in the axis of symmetry, then it will lie somewhere around about here. So there's the point M. And we want the coordinates, and they specifically said write down. So it's important that you know when they say write down, it's something that you can see with inspection. You can just write down the answer. Only thing is, in this case, we would need to know the coordinates of C. I don't know the coordinates of C yet. So I will actually have to go and calculate that coordinate of C in my eyes. Look at this, just basically finding the y-intercept of the parabola, which means make for x 0. So that is the first thing that I would want to do. Y is equal to 0 minus 4 squared minus 9, and that gives me 7. Which means the coordinates of C will be 0 and 7. And if this is a reflection and axis of symmetry, then if this is 7, then the y value here must also be 7. The only thing is it's just the reflection, so that means 4 units, because remember this was at 4 and negative 9. So that means from 0 units to this side will be 4 units. And then I need to do the jump again. So from 4, another 4 units on, which means that that will be 8. So that is why I say it is a simple inspection that you can use to get this answer. So the coordinates of M would then be 8 and 7. 4.4. Determine the equation of G. So now looking at what I've received now, since I've already got the C value, then it means I can use that 7 there. But what I would need is the gradient, because remember this is a straight line, so I've got y is equal to mx plus c. I would need a gradient and I would need a point or the y-intercept to substitute in. So I can substitute the 7, but I do not have the gradient. But you actually do, or not yet, you have to calculate it. But since this E is at 4 and -9, and remember this line is parallel to the y-axis, which means that the coordinates of D would also be 4 and 0. So I can now go and do get the gradient from here. It's a change over the y over the change over x. A change over y over the change over x. Either you use that method or you go and you say you can use your gradient formula, which we normally use in paper 2. But the gradient will be delta y over delta x. In this case, means that we had 7 units at the top and 4 units at the bottom, but it's a negative line, so that means it will be -7/4. So if you don't want to do it that way, you can go and you can say y2 minus y1 over x2 minus x1, but we normally don't need it in paper 1, but it can happen and you are allowed to use it. But this will then give you 0 minus 7/4 minus 0, -7/4. Same situation. So now I've got my gradient. So the equation will then be y is equal to -7/4x and then plus 7. 4.5. Write down the equation of, and remember this is g. So I want now g of -1. If they say that, then it means that they want your inverse. And they want it in the form of y is equal to. You've got this equation. And what did we learn from inverse functions in term 1? We need to swap our x and our y values around. So then I will have x is equal to -7/4 y plus 7. But I'm not allowed to leave it in this format. I need to make y the subject. So that is why they said in the form y is equal to the following. So I will isolate and make y the subject again, which means I will then, I'm thinking I'm going to swap these two around to get rid of negative. So 7/4y is equal to -x plus 7. Then it's also within a better format, more closer to the standard form. And then I need to get rid of the 7/4, which means technically I divide by 7/4, and I need to divide by 7/4 and divide by 7/4. That will be my quickest route. So then I will have -4/7x, and this side will be plus 4. You can use your calculator if you're not so in tune with your fractions. Then 4.6, I'm just going to do this on here, this side, because it is a short answer. 4.6, for some, you guys might find this more difficult question, but it's more of an interpretation question. And I just quickly want to go and look at that. So the question is asking the following, right? So it could have also just been written like this: f of x smaller or equal to 0. But this is a multiplication sum. I know some of you get confused because there is an x. It is a bit of a more complex question, but it's definitely something that is doable. So when I have a multiplication, you need to ask yourself, this answer, what will I end up having? Because this question here, it says smaller than 0. And I need to ask myself, what values gives me smaller than 0? The values that are negative are smaller than 0. So I need to ask myself, what times what gives me a negative? It will only be a positive and a negative, or it will be a negative and a positive that will end up being a negative. So I'm going to take each condition on its own. Right, so if I look at the top condition, I then have x that must be positive, and this is y that is negative. I'm only going to look at the f function, and I'm going to look at my x values. So those that are getting confused with the fact that it just says x, that is basically just speaking about for x values. If I want to say x must be positive, then I'm going to close off the negative side of my x-axis. Remember, don't get confused on where your axis is. Your axis is your y-axis and your x-axis. I'm going to close the negative side of my x-axis. And why am I doing that? Because I said that x must be positive. So I'm only going to look at the positive x values. Then the second part of that condition was that the y values for f must be negative. So where is this y values negative of the f function? And the f function is a parabola. So my y values are negative here to here. Right? And what am I looking at? That would be my x-intercepts. Remember, we've already calculated them 1 and 0 and 7 and 0. Right. So between 1 and 7, this function is the y values are negative and my x values are positive. So I write that, I can either write it in inequality form or interval notation form like we've done. So if I do that in interval notation, I believe that would be my easiest route. Then it means my x must lie between 1 and 7. But the question is, was the question including 0? It was, therefore you will include your 1 and your 7. If you wanted to write it in interval notation, I will do interval notation. This is interval. If you want to do it in inequality notation, I will do that afterwards. I just want to finish the question. So I'll do it here, then you can see it. So between 1 and 7, equal. Very importantly, the arrows must both face to the left. Right? We spoken about that yesterday. Then we still need to look at the second condition, right? So where I say x must be negative. So now I'm going to close off my positive side of my x-axis. And then they are asking that your y values must be positive. So my parabola is here. My y values are positive, and it's going all the way to negative infinity, right? Because that suggests it goes on, which means that I need to say all the x values left of 0 or below 0. So I will write it, if I write in interval notation, I will write x element from negative infinity to 0. I can include 0, but I'm not allowed to include negative infinity. Okay, so or you write it in inequality form where you say x smaller or equal to 0. So there were two answers, and that is why it counts 4 marks. There were two answers for that one. So either you do interval or you want to do that plus this, you can mix and match. It's up to you. All right. So we have completed 4 point question or question 4. Go back to the PowerPoint. And now we are going to look at question 7. So we've done a hyperbola, we've done a parabola and a straight line now, and now we are going to do an exponential. So very fast, I'm going to give you 8 minutes to complete question 7.1, and that will be on your page 10, and good luck. All right, good girls. I'm sure that was enough time. So let us look at 7.1.1. So our function that we've got is an exponential function. The first question was calculate the coordinates of the y-intercept. So straightforward, we know we need to make x 0. So 3 times 2 to the power 0 minus 6. And that is 3 times 1, which is 3 minus 6, which gives you negative 3. But they say coordinates, so 0 and negative 3. Right, and then 7.1.2, calculate the x-intercept, so make y 0. So this is again our exponential equation practice. So we will have to take the 6 over, it will be 6 is equal to 3 times 2 to the power of x, divide by 3 on both sides, and then we will have 2 is equal to 2 to the power of x, and then 1 will be equal to x. That coordinate will be 1 and 0. 7.1.3, they want us to sketch. So if I need to sketch, I'm going to do it here so that we can still see our values. And we've got x-axis, And we need to do the following. Remember, we said by an exponential equation, we have one asymptote, and that one asymptote is y is equal to q, which means I will have an asymptote by -6. So we'll make our asymptote -6. And then we've got our y-intercept here at -3. And we've got an x-intercept at 1. 1 and 0, 0 and -3. And our function, our a value is positive, which means our function is supposed to be at the top of our x-axis. But the question is, it's a whole number, which means that it's an increasing function. So we will be increasing. There we go. Right, so there is our exponential equation. The next question, 7.1.4, they were asking us write down the range of f, which means range refers to your y values. Over what y values is this graph stretching? So it doesn't touch -6, but it is everything above -6. So easiest way to write it will be y greater than -6. Or alternatively, if you want to use interval notation, you've got y is an element from -6 to positive infinity. You can't include -6, but you also can't include an infinity. All right. That was 7.1.1, 7.1. Then we are going to move on to question 7.2. Now, grade 12, so I just want to do this. So we will not be doing question 7.2.4 as well as 7.2.5. So I might take out a few minutes, like extra 2 more minutes. Instead of 10 minutes, I might only give 8 minutes. I'll see how I feel, maybe 9. Right? So please, we will do 7.2.1, 7.2.2, and 7.2.3. So only do these 3 questions. I'm giving you about 9 minutes to complete 7.2 because we've got some reading. Good luck. Right, grade 12, we are going to look at our answers. So you had 9 minutes to complete that. If we look at the following graph, we've got our parabola, we've got our straight line. They did not give you the equation of the graph, but that is in standard form. And they also didn't go and give you the entire equation of the straight line. They left out your y-intercept, which is d. Right, so now the first question asks you to determine the value of d, which is the y-intercept from the straight line. But that means it will also give me the coordinates of r. So how would I get that value? So how many unknowns do we normally say there are here? We've got y, we've got x, and then we've got d. But x and y is not seen as unknown because the moment I replace x and y with a coordinate that has an x and a y value, then it means I only have one unknown, which would be d. So then I can solve it. So the goal would be to take a coordinate on this line, which I have, which is the point t, and substitute it into that equation. So I will have y is equal to negative 2x plus d. I'm going to substitute, my apologies, now you can see 6 and 0 in. So 0 is equal to negative 2, 6 plus d. That is negative 12. So 12 will be equal to d. Now 7, that's 7.2.1. 7.2.2, that means I have my value, which is 12 there. So that's negative 2x plus 12. But now they are asking for the full equation of f in that specific form. But let's go and see what do I have of my parabola. From the answer that I've got here, I can now complete and say that the coordinates of r would be 0 and 12. So it's important for me that I write that coordinate in, because then I will see what is it that I have. So I've received my x-intercept and my x-intercept. And the reason why I'm pointing that out is, remember when we did our stuff right here in the beginning. So that page, we said that we can have the parabola, not on this page, but there is 3 different formats, and I don't think I've got it here, but it's on our PowerPoint. But we have the y-intercept form, so that the y-intercept, the x-intercept form, the turning point form, as well as the standard point form. So I've only received my x-intercepts and I've got a y-intercept, so which means I'm going to use that form. So here I go. The equation for that was y is equal to a, x minus x1, x minus x2. Going from what I know here, if my x-intercept is at -2, then it must read that x is plus 2. And then the other one was at 6, so it will be x minus 6. Then I need to sub in my coordinate of 0 and 12. So then it will be 12 is equal to a, 0 plus 2, 0 minus 6. That gives me 2 and -6. When I multiply, gives me -12a, which tells me that a would then be -1 if I divide by -12 on both sides. Then I need to put it back into this equation. So a is -1, but I've got x plus 2 and x minus 6. So why is this necessary? Because the question asked to give you the equation in the standard form, which means I need to multiply out from this x-intercept form and get into standard form. And that we've done for quite a few years now. So it is x squared minus 6x plus 2x minus 12. And then we need to still multiply now negative. This gives me -4x. So now when I multiply, it will be -x squared plus 4x plus 12. Right, 7.2.3. I needed this in order to complete my next question. So what they gave me that, for in case you aren't able to find it, you can still continue with the rest of the question. So once I've got that now, they say calculate the coordinates of the turning point. If it is in standard form, we've learned from what we went through in our revision that we have to use the formula -b over 2a. Or alternatively, we can use our grade 12 method of the first derivative, which I will gladly show you now. So we've got our a value, our b value, and our c value. So that will be -4 over 2, and a will be -1. That gives me -4 over -2, and then x will then be +2. But then I only have my x value. I still need to go and substitute it back into my original to get the y value. And that will equate to 16. So my turning points coordinates would be 2 and 16. If I was going to do the first derivative route, what will I do? So if this was my original equation, that is fx is -x squared plus 4x plus 12, then I must first do my first derivative. And we know that we multiply to the front, so -2x and subtract in 1 by exponent, plus 1 times 4 is 4. Then we've learned that we need to, the gradient, because this stands for gradient, so the gradient at the turning point is 0. So then it will be 0 is equal to -2x plus 4 to find the x value where the gradient is 0. So 2x is equal to 4, and x will be equal to 2. And then obviously I will complete as the normal by putting it back into the original. All right, so that is just another method that we've now learned in grade 12 that we are also allowed to use. We don't have to go back to the grade 11. It's okay. So let's look at our next question. We need to move on to question 3 onto your page 7 for me, please. We go on to question 3. And there is 3 questions there. They've given you the equation y f of x is equal to 3 to the power of x, which is the exponential graph. I'm going to give you 8 minutes to complete this one. Thank you. Right. Grade 12, let's look at the questions, answers. Question 3.1. First of all, let's quickly see here that is an exponential graph. We can see it's been drawn for us. They say f to the power of -1, which means that is your inverse. Right? So when we do exponentials inverse, we've done one already for the straight line. We now need to do the inverse for the exponential. So 3.1 would be our original is y is equal to 3 to the power of x. So what did we learn? That we need to swap the x and y value around. So it will be x is equal to 3 to the power of y. That normally gives you your first mark. So this question, it only counted 1 mark. But these days it's counting 2 marks because you see that's a 2010 question. But nowadays it's really counting 2 marks. So normally you get your first mark for showing that. Then the second mark you get for putting it in the right format. So we have learned, remember yesterday I did that one by the exponential equations. I also did a log. I used the log there and I wrote out a formula thing for you where it says exponent. So the exponent is y is equal to log the base and then the subject. So the answer will be y is equal to log 3x. Then they say sketch the graph of the inverse. So that you must read and see how they are showing it to you. So inverse must be sketched as well as this part. So I'll get to this one now. Let's focus on the inverse first. So if this is my original, I normally say use your original to go and draw. So on your original, we know that this is the point 0 and 1. Which means that when I want to go and draw my inverse, I'm going to be drawing it this side because why? I know I've got to reflect over the line y is equal to x. But then I normally say I need like one more point to just help guide me, or even two more points if it needs be. So I can read this one off here. At 1, we've got 3. But if I couldn't read, remember you can put, I normally say take -1 and 1 for the x values and substitute that in here into your equation. So then this will give me the point -1 and a third, because it's 3 to the power of -1, which is a third, and that point will be 1 and 3. Then you use that to go and draw your inverse function, because basically that needs to happen is this needs to flip around. The x and the y values needs to swap around. The same there and the same there. So then I can easily go and draw those three coordinates to help guide me. So I've got negative, it will now be, if we had -1 and a third, it will now be x is a third, and then we are down to -1. So x is a third and -1. And then 1 and 0, as well as 3 and 1. Remember, your x-axis was your symmetry line. You don't see it, but it is there. Your not your symmetry, your asymptote. So your x-axis was your asymptote. So when obviously it needs to also swap around, then your y-axis will become your symmetry line. So technically there's a symmetry line there. We never draw it in, but we know about it. So that means it will come through here, it will approach this the y-axis, but it will never touch. Then next, we are going to look at the second part of the question that they asked us, this. So we need to be able to interpret what this is saying. So since the -2, it's a shifting. So it's either vertical or horizontal shifting. So I need to determine which one would it be. If it is on the inside of the bracket by the x, then we know that it's a horizontal shifting, which means we've moved left or right. The question is just, have we moved to the left or have we moved to the right? If we say -2, remember in functions, it will be the opposite. So -2 on your number line shows that you're going to it's -2 on the left-hand side. But because the functions, it's the opposite way around. This actually just means that the graph has moved 2 units to the right. To right. That's what this part means. Okay, so, but it would be a difference if I say this, if I say -2 on the outside of the bracket. That will tell me that my graph has moved 2 units down. Right, so it's where your -2 is placed. Inside means horizontal shifting. That means my graph has moved left, either left or either right. And on the outside of the bracket, it will be either up or down, vertical shifting. So that means I can literally just take what I've drawn here and I can shift that 2 units to the right. Which means the first part what I'm going to do is I'm going to shift my asymptote. So if my asymptote was here at 0, if I go 2 units to the right, 1, 2, my new asymptote will be here at 2. Right, that's the first part. Then I'm going to go and literally just move my points that I've got 2 units to the right. So the new point here, this was by a third. Now it will be by, wrong place, my apologies. Ignore that point. It will be by 2 and a third. So 2 and a third and -1. Just next to that is asymptote. And then this was by 1, so then this will be 3 and 0. And then that was by 3 and 1, and now it will be by 5 and 1. And I can draw. There we go. Please do ignore that point there. That was 3.2. 3.3. This is more of an interpretation question. The question that they are asking you for use your graph to solve for which values of. Now we're using which graph? They're talking about this one here, so I must use this graph. But this technically means y less than 1. So the y value for this graph. So let's look at ways that y values less than 1. And if I have a look, here is 1 for this graph, but it goes down on the left-hand side, which means I'm referring to this section here, less than 1. And it has to be for the entire less than 1, which means it goes on here all the way to this. But the question didn't ask for the y values. The question asked, answer for which x values the y values are less than 1. So let's go and see where are my x values at. So it will be here at 5. And then it will approach 2, but will it touch 2? No, it will not. So it will be between 2 and 5, but not including 2. So when I answer the question, it will be x is an element from 2 to 5. All right, was the question including? If I look back at it, can I include here? No, so I cannot include the 5 because it wasn't including. So a round bracket, and I cannot include the 2 based on the fact that it's an asymptote, so I'm only approaching it, so I cannot include 2 as well. That will be interval notation, or alternatively, you can write it in inequality notation. So x will lie between 2 and 5. Remember, it's not including, so no equal signs at the bottom, but the arrows will always be that way. Signs will always show that way. Right. So that was question 3. 12. So next up, we have question 5. Just get there. Question 5, another exponential graph, more focusing now on inverse functions, but it will be from the 5th March 2018 paper. On your page 10 of your notes, you've got 8 minutes because it's only 8 marks. So if I can give you that 8 minutes to complete question 5, you may start. Okay, time is up, so we are going to look at our answers again. So question 5.1. Question 5.1. Yeah, it's question 5. They say the coordinates of t, and you just need to go and know it. So this is a knowledge question. Because this is an exponential graph, normal standard exponential graph, then you need to know that the coordinates of t will always then be 0 and 1. Right, so that is knowledge that you need to have. Right, so you didn't need the equation for that, so t would be 0 and 1. 5.2, the question is asking for the value of a, but you can use the other point that was given to you to substitute into the equation. So 9 is equal to a to the power of 2, which means that you obviously square root, but you've got plus minus square root. But why will I only use the positive 3? Because it has to be a positive function that's on above. So it will only be the positive 3 that I'm going to use. So a would be 3. Then 5.2 or 5.3 now, the graph of h is obtained by reflecting g in the y-axis. So I'm going to reflect my graph in the y-axis, which means my graph will now go like this for h. Write down the equation, but we learned in grade 10 already, when we reflect in the, or even prior, even grade 8 and grade 9, when we did our reflections. Then when we reflect in the y-axis, our x value needs to change. So if my graph is currently this, and this would be g, 3 to the power of x, then to obtain h, then I need to make a sign change for my x value. So if I reflect in the y-axis, my x value changes, so it will be negative x. Cannot leave it like that, so I'm going to have, this is technically 3 to the power of negative 1, don't need to show me this step, so it will be a third to the power of x. Okay, so then 5.4. 5.4 is a bit more of a hefty sum because it obtains a lot of knowledge. Again, it is interpretation. Right, so the first thing that I want to do is I want us to go to the question. This year stands actually for Y. So they want to know, but in for this graph. I don't have the graph. I don't see the graph in front of me. I'm technically going to go and draw it now. Just as a quick sketch, so it helps me and interpret the question easier. But if I didn't want to use the graph, I am going to reinterpret this stuff because this is my log, which is it's already my inverse. So if I want to know for which values of x my inverse, the y values lies between 0 and 1, then if I want to take it to my original, which I see in front of me, then the x values must lie between 0 and 1. And I want to know for which y values does my x values lie between 0 and 1. This is when I swap my x and my y values around. So I can look on my original equation for the answer or original function for the answer. So I know that my x value is 0 here and the y value is 1. So this is one of my coordinates that I'm going to use. But then I still need to know what is the y value when x is 1. So I go and I place that 1 into my equation that I've got, which is then 3 to the power of 1, which means it will be 3. So when x is 1, I will have a coordinate of 1 and 3. Right. So the question is then for which y values, so it will be between 1 and 3. Right, so my answer will then be, you can't answer for y, you will then answer for x, but x will lie between 1 and 3. If you can't see it the way I've now shown it to you, then your other option is to still have these coordinates. You will still need this, but then you will have to go and draw, just doing it like this for now. You will have to go and draw the inverse function, which means I will have 1 and 0, and then this will swap around and I will have 2, 3, 3 and 1. Remember, goes through here, goes through there. Right, so now visually you'll be able to see it. So for which, now I'm only looking at this one, for which values of x is the y values between 0 and 1. So here's my y value 0 and here's my y value 1, which means I am referring to this section. So for which values of x will that be? Between 1 and 3. Between 1 and 3. Right, then it will be like this. You either write it like that, or alternatively, you can write it in interval notation between 1 and 3, not including. The question also didn't include it, so that is why I do not include it. Okay, I hope that you understand one of those two methods. Then I am not certain, I think we've got enough time, maybe 5 more minutes. So let's just see our next question. If I can ask that we do the first two, right? So for me, it's important to do the first two. That's 5 minutes. That we can do the first two questions of question 8. Right? Quickly, I'm going to give you 5 minutes to complete that, and then I will just quickly go through that, and it will be done. Thank you, Red 12, for your hard work so far. So page 11, question 8. Right, Gurtas, I'm going to stop it here so that we still have time to just quickly answer. If I look at the first question, they're asking you for which values of x is the y values greater than -9. So that means, or equal to, that means I'm talking about this section here. So that will be between 0 and, we work it up, between 0 and 3. Then write the equation of the inverse, and that is why I asked to do this question. Include all restrictions. So currently what we've got here is we've got y is equal to negative square root 27x. Right, I'll talk about the restriction part just now. Sorry, this was 8.1.1, was x is between 0 and 3 including, right? Or x including between 0 and 3. This is my equation. I want to do the inverse, which means I need to swap x and y around. So x is equal to negative square root 27y. Then I'm going to square both sides to get rid of my square root because we learned that yesterday. Can leave the negative there. Then the x squared is equal to 27y, and then I'll divide by 27. So it's x squared over 27 is equal to y. All right, but now how do I explain, or how do I do the restriction? Because the current restriction is x greater or equal to 0. So remember that this thing will reflect around the inverse, which means that I'll have my graph that will go here. So my x values will now be everything to the left of my 0. So which means all my negative x values. So it will then be x smaller or equal to 0 as my restriction. All right. And 12, so we'll just end the session off. Stop sharing. All right. Thank you very much, Grade 12. It was a pleasure to be able to tutor you these 2 days, and I really hope that you do all the best by the time we get to the end of the year, and that you take all everything that you've learned. And again, I just want to say thank you very much for your hard work. It is exceptional to see that there are so many of you guys that are willing to put in the extra mile to get where you want to get. Have a great day and keep well.